All right. Good morning, Michaela. So I told you I would get another video ready. I have a few when I'm going to look at some Desmos stuff. But before we do, there's another thing I would like to kind of write down to show you. So let me share my screen. Let's see here and look through a few things. So all right, I don't know, you might be hearing those little sounds. That's my tablet connecting and not connecting. Hopefully it works okay. All right, so what we're going to be doing and looking at is the limit as x is approaching either positive infinity or negative infinity. Okay, so what that means in a second when we look at Desmos, and again, kind of like the first time we did something, when we're looking at Desmos, we're just going to look today and then eventually hopefully try to find some shortcuts and find some things to help us out, right? A little bit in the past, we've kind of talked about this because, for example, if we look at a parabola, like both sides go up. So that actually means this side on the left, and once again, the left side is negative infinity. The left side is going up. I'm really sorry. This does not always like the infinity symbol. The left side is going up. So on this graph or this black equation right now, if I said, what's the limit of x approaching negative infinity of my equation, that's something like x squared, the answer would be positive infinity because this side is going up. The limit of this black function, which is something like x squared, on the right side, well, what's the right side doing? Also going up. It's going to be also positive infinity. Do not get led to think that if infinity is where you are approaching, infinity is your answer. For example, I'll erase everything. Let's say we're supposed to find the limit as x is approaching infinity. And since I'm using black now, let me draw on here. I believe in the past, maybe not, if you type in 1 over x into Desmos, which I don't have that typed in right now, but I know the graph on this side goes like this. And the graph on this side goes like this-ish. It's a little bit off, sorry. The equation is asking what is x, the limit as x is approaching infinity. Infinity is as you go towards the right. What is happening to that red line, which is my curve, and the black line, which is the x-axis? They're actually getting closer and closer together. The x-axis is actually equal to 0, because if we were to touch it, it would be 0. But remember, we're not actually going to touch it. This red line is going to get closer and closer. It's that asymptote idea. And we're going to get closer and closer to 0. So that means the limit as x is approaching infinity for 1 over x is 0. Now, I'm using these right now to help us out with that. Give me just a couple seconds to click the right things and get to the right place. All right, so let me move that to the bottom. And all right, I want this one first. All right, so let me move because I think you see my whole screen. I'm not really sure. So if I look at this problem right now, okay, the red equation is the one we're looking at. If I look at this, once again, let's see how it just shows up as that little, let me pull this up too. So you can see a little bit of a different type of cursor. Again, it has this weird asymptote thing in the middle. That is true. We're not looking at that weird asymptote in the middle. Michaela, would you please tell me what is true as this red line forever goes to the right? Would you agree that this line, as it goes to the right, is going up? Up would be positive infinity. So this limit, if this was the equation, and again, sorry, limit as x is approaching infinity of this x squared plus 6x plus 5 all over x minus 3 You know what? It doesn't even matter that there's something hiccup or weird at x minus 3. What does this right side do? Goes up. Therefore, the answer would be infinity. What does the left side do? Since the left side goes down, if I change this up a little bit, so let me even change colors. If we said, what is the limit as x is approaching negative infinity? Since this is going down, the answer would be negative infinity. So again, you might need to like rewind and pause and write things down. Sorry for the different answers on the left side, since it's going down, that's why I have that, okay? Let me click a few things here. Maybe you've paused and whatever. I'm gonna look at this one. I'm gonna change it just a little bit because of what this one is. Oops, wrong. And even though, again, it has this asymptote here in the middle, and let me use the highlighter real quick. Even though it has this little hiccup, excuse me, right here, doesn't matter. Look at the sides, look at the ends. What does this right end do? Oops, sorry. That right end goes up. So that would mean if I was studying this blue graph right now, and I would say, what's the limit as x is approaching infinity of x cubed minus 2x squared minus 5x minus 9 all over x minus 5. Infinity means the right side. What is the right side of this graph doing? Going up. Infinity would be your answer. Again, if you want to pause and write that down. But I'm going to continue talking because we're not only worried about the right side, we're also worried about the left side. The left side would be negative infinity. Negative infinity is as I go to the left. What is the left side of this one doing? Actually, because this kind of ends up having the shape of a parabola, this would end up being positive infinity as well. So I have a few more for us to click through and look through. I think I'm going to have to change the scale again for this one. All right, and yeah, let me change this. Here we go. Sorry. I thought I knew what ones I wanted on all of these, but this one I'm not getting right. Let's see, 20. Oh man, I'm sorry, Michaela. There we go. All right. So look at this green graph, please. Again, ignore the hiccup in the middle. Ignore that hiccup in the middle. What is this graph doing as it goes to the right? I hope you said going down. So if you want to write down negative x squared plus 8x minus 3 all over x plus 2, the limit that way would be infinity. Nope, my fault, my fault. You said that graph was going down, so that would be negative infinity. And then let me rewrite this, probably alongside you. What would this left side be doing? It would be going up. So this one is a little bit flipped because again, my line would go down like that. Like if I look at this, it looks kind of like a line and it goes down to the right, but up to the left. So Michaela, in a minute here, I'm going to be looking at something else, but I want to make sure that you had all of those written down. So again, if you need to rewind and rewrite, excuse me, some of those limits and like those three things. But what we're going to do is kind of move on to some other graphs. that are a little bit different. So I know this sounds weird. I think I can do this right now. There we go. What would you like to tell me about these three equations? There's something kind of unique about these three equations, and you might not be able to look at it yet because you're like, I don't even know what I'm supposed to be looking or comparing it to. So if you give me just a second, I need to click on just a few different things here. All right, I would like to look at this one next. And once again, if you want to, from the beginning, the last question I ask is like, what's true about these three equations? So you're not going to notice something different about these three equations compared to the last three equations. So if I open this up again and we're able to write on the board, let's think about this again. Except if we look at this first equation, this graph right here, and I already go all the way out to -500 and +500. It is not going up forever. It looks like it's just reaching this nice stable line. And this nice stable line would be at 1. So if I go forever to the right, like I'll even do it for a minute here. If I try to click and drag, do you see how this red line does not appear to be going up? It appears to just be staying right at +1. Okay. That is because this limit is 1. And so on this one, it actually doesn't matter if I look to the right or to the left. Oops, my pen just disappeared. Hopefully it pops back in a minute here. I heard it. There we go. The limit as x is approaching infinity of x squared minus 6x plus 5 over x squared plus 2x plus 1. Once again, today we have to look at the graphs. As I look at this graph, as it goes forever to the right, it looks like it's stabilizing itself at 1. So the limit would be 1. It doesn't matter actually if I go to the right or to the left. Both sides, if I go to the right, it looks like it's getting close to 1. If I go to the left, it also looks like it's getting close to 1. All right. So what I would like you to do is pause the video. Type this second equation right here into your Desmos. You might want to set up the scale very similar to what I have the scale over here. So let me click this. You probably want to set up the scale with this being like -500 to 500, -5 to 5. That's probably going to be pretty helpful. Plug it in and see if you can figure out what the limit is. So you're going to pause. I'm going to continue the video, but I am going to erase some things. So if you paused and you're back now, you should have erased, not erased, you plugged that in. You're still finding the limit going both sides, but we're going to get 3x squared plus 2x plus 5 and x squared minus 8x minus 3. The limit to this one should have been 3 for both positive infinity and negative infinity. So hopefully you plugged that in, figured that out. If not, I'm going to do something real quick here just so we can see the answer. Turn off red, turn on blue. If you look, blue is approaching 3 from the left and right. So once again, go to Desmos, keep the same scale, plug in this bottom one, see what you get. All right, I'm going to have to do some erasing quick here because it's just easier for right now the way I'm doing it. But you should have plugged in and you should have, I'm not going to write the information in, but with this last one, for the thing that is the 4x squared equation and the 2x squared equation, both limits should have been 2. All right, so once again, I want you to kind of look at, and hopefully so far you've written down all these limits, okay? Let me do just a couple things here. Michaela, so far, oops, I need to get off this app just a second. So far, we've been looking at these equations. So would you please look at these 3 equations? Math is always about a pattern. So what is similar about these 3 equations right here? And the first ones we studied were these. What's similar about these 3 that would be different than these 3? Okay. And if you notice, I have one more Desmos app. So I'm going to click over here. We're now going to look at these equations. And these equations are kind of tricky a little bit. Excuse me, I did not mean to click that. I was trying to click this. Because of the way this works, and I know it's there, we're looking at the red line here. This is somewhat similar to the last problem because it looks like it's just a horizontal line, but this horizontal line goes left and right exactly on the x-axis. And I believe very towards the beginning of this video, I said if it's on the x-axis, it would be 0. So this limit, as x is approaching infinity, and actually, quite honestly, it would also be negative infinity because it does not matter if I look towards the left or towards the right. It looks like I'm right on the x-axis. Since I'm right on the x-axis, the limit of both of these would be 0. Okay? Because as I go towards the left and towards the right, I am right on that x equals 0 line. Excuse me, the y equals 0 line on the x-axis. I said that a little bit backwards. So same thing, plug in those other 3, excuse me, 3 total, plug in these other 2, see what you get. All right, maybe you paused for a second and plugged in the second one. Even though the equations changed up, the limit for that middle one would still be 0. Try the bottom one. Hopefully you paused and did it. The limit of the bottom one would also be 0. So Michaela, I'm going to try to do something here. I don't know how well it's going to work. Okay. I know that with, what is going on? I know that with these, I can usually do like, if I go like this, I can get at least, okay, I'm going to have to make them a little bit smaller. I don't want to do half screen. Oh, there we go. There we go. All right. So I'm going to have to make all Desmos works as 1. So if I make 1 smaller, they all are going to get smaller. But Michaela, what I need you to do, I need to make it a little bit smaller, is pay attention to these 3 equations. Now I do need that open again. Remember, each Desmos I had put together was like similar. And so since each Desmos I put together was similar, you should have the equations written down. But what I want you to study for a little bit and look for, and I apologize, that keyboard thing is right there. These 3 equations are very similar in some form. These 3 equations are very similar in some way. And these 3 equations are very similar in some way. What we're going to need to do is determine how each equation is similar, why it is similar, what causes its similarities, and therefore, how can we look at a problem and know which one of those 3 to group it with? To tell you the truth, these are the 3 different ways they could be grouped. So if we look at it, how are we going to know which of those 3 it goes with? So study those differences, please. Try to figure something out. I don't know if you're going to get to that today or tomorrow. The video, I have no idea exactly how long it's going to be. It doesn't have it. I don't have a timer going today. And I know you have to pause a little bit and you might have to rewind a little bit and watch and listen a little bit again. But we're going to try to figure out what the pattern is between these 3 different patterns, excuse me. And then just like we did before, once we know how to do something, how can we not use Desmos every time, but know what to do? Okay. So again, I'll send you this link. I'll check in with you. I'll tell you to check in with me, but please watch this video. And when you're done watching this video, let me know so I can kind of send you another video. Have a great day.